A Lewis diagram is a very simplified representation of the valence shell electrons in a molecule. The group number of an atom represents the number of the valence shell electron. It is used to show how the electrons are arranged around individual atoms in a molecule. Electrons are shown as dots of a bonding electrons as a line between the two atoms. The dots can't be just drawn anywhere. Instance, imagine a square around the atoms and not more than two dots should be drawn on each side of the imaginary squares. The picture below shows the Lewis diagram of a chlorine atom, which has 7 valence electrons. It also has not more than 2 valence electrons, which is also drawn as the dots in each side of the imaginary square. In covalent bonding, atoms share valence electrons in order to get a full octet or duet for H, which is hydrogen. As you can see, this is the Lewis diagram of hydrogen. Each hydrogen atom has one electron, one valence electron, and by joining another hydrogen, which has also one valence electron, it forms a duet. Shared electrons are counted as owned by both atoms, so both atoms are satisfied. So we just draw a line between the both hydrogen symbols. One line represents single bond which contains 2 electrons. 2 lines also represents double bond which has 4 electrons. As you can see in the example, both the oxygen atoms are sharing its 4 electrons in total and forming a double bond to satisfy its octet rule. If it has 3 lines, which is represented as triple bond, and also it means it has 6 electrons in it, which has been shared. Both the nitrogen's atoms in the example are sharing 6 electrons in total and forming a triple bond to satisfy its octet rule. The most important thing that you should always remember is the main goal is to obtain the best electron configuration. The octet rule and the formal charges needs to be satisfied.
Now we learn how to draw a Lewis diagram. There are 5 important steps to draw a Lewis diagram. We use water H2O to this. First step, count all the valence electrons. There are 8 valence electrons in total. Second step, determine the central atom. Oxygen is the central atom because there is only one. Third step, draw single bonds to the central atom. It is shown there. Fourth step, put all remaining valence electrons on atoms as lone pairs. There is 4 remaining valence electrons and it go to oxygen because hydrogen can have 2 valence electrons only.
The fifth rule is turn the lone pairs into double or triple bond to give every atom an octet or duet. For this, there are 2 electrons of hydrogen and 8 electrons of oxygen, so the Lewis diagram is complete.
Over here we have sulfur oxide. So in order to draw a Lewis diagram for sulfur oxide, you need to calculate the valence electrons. That's the first step. Second step, you need to determine the central atom, which in this situation the central atom is sulfur. So you need to draw sulfur surrounded by the 3 oxygen atoms. Step 3, draw single bonds to the central atom. It's basically the line that is connecting the oxygen atoms to the sulfur atom. Those 18 electrons are also known as lone pairs. Step 4, so you need to calculate the remaining electrons in the atoms, which are also called the lone pairs. So how to calculate the remaining electrons? So 24 minus 6. 6 is the amount of electrons that are used, 24 is the total amount of electrons, and you get 18. 18 is the amount of electrons that are not used. Step 5. Turn the lone pairs into double or triple bonds to give every atom an nucleus. Since sulfur has only 6 valence electrons, you can share the lone pairs from one of the oxygen atoms and make it have 8 valence electrons, and hence it will form a double bond. And because of the double bond between the sulfur and oxygen atoms, every single one of the atoms will now have 8 valence electrons.
Hello everyone, I am going to explain about dot and cross diagram. We can use dot or cross to represent electrons in an atom. Protons and neutrons are at the center of the nucleus. Electrons orbit the shells or orbits around the nucleus. Protons have positive charge, electrons have negative, and neutrons have neutral charge. Here is the example. Protons and neutrons that are nucleons will be in the middle and electrons will be orbiting around them. In their shells, only 2 electrons can be filled in the first shell of an atom. The second shell will have 8 electrons and the third will have 8 electrons. For example, oxygen have 8 electrons, so the first shell will have 2 electrons and the second shell will have 6. Another example is calcium. Calcium have 20 electrons, so the first shell will have 2 electrons, the second will have 8 and the third will have 8 electrons, and the last shell will have 2 electrons, the remaining one.
So here we put oxygen as an example for you guys to show. Oxygen atom has 2 shells, the first shell and the second shell, or you can call it first orbital or second orbital. First shell has 2 electrons in it. As we said, the first shell can hold only 2 electrons and not more than that, and the second shell has 6 electrons. So the total electrons of oxygen is 8. It's simple that the last shell or the last orbital is called valence shell, and the electrons in those are called valence electrons. Back to the oxygen, the second shell of the oxygen atom is a valence shell, and 6 electrons in the second shells are called valence electrons. Now we know that second shell can hold electrons up to 8 electrons. Here now oxygen, we have only 6 electrons in second shell, so we have 2 more places for the electrons to come in. Not only dot, you can also use the cross to show the electrons in oxygen. This 6 an oxygen ion. An oxygen atom has gained 2 electrons as it has place for them in valence shell and becomes oxygen ion. Now remember that electrons are negatively charged, and that is why we write 2 negative, or you can write -2 at the top right of the drawing, and the drawing should always be in the square bracket as it has shown, and the charge always should be written outside of it. You can also draw the cross for the original electrons and draw the dot for the electron that has gained. Dot and cross diagram can also use in chemical bonding such as covalent bond. By using it, we can clearly see and understand how electrons are shared with each other and create a bond, just like sharing your snacks with your friends and get a better friendship. Simple, right?
Thank you for watching the video. Make sure you like, comment, and share the video with your friends. Don't forget to subscribe and click on the notification bell icon to get notified every time we upload a video.